Hello everyone! This issue is discussed in Video Engineering Transition. Significance, assessing methods for functions and their carriers, refers to the theoretical part of Block 1, a short course of value analysis, of the training course Cost Engineering. The issue deals with such issues as the general concept of determining relative significance and importance, the stages of value analysis and value design engineering, at which significance is determined, the principle of forming a flowchart, significance, relevance, the concept of engineering transition, a list and comparative characteristics of the method of determining the significance used in domestic school of value analysis and value design engineering, and the methods set out in the VDI series standards, visualization tools, and automation of the process of assessing the significance and relevance. The following keywords will be used as part of the discussion of today's topic. This issue introduces new concept, namely engineering transition and engineering transition line. The stage of determining the significance of the functions of their carriers through the selection and application of methods for determining significance, along with stages of setting the degree of abstraction of consideration, choosing the classification of function used, formulation of functions, and determining the degree of satisfaction with the function in the process of forming structural model are critical stages of the value analysis in the context of increasing the degree of reliability of the analysis results. Simply put, in a row, determining the significance at given a level of abstraction crosses out all previous and subsequent stages of the value analysis, even if they are performed correctly, and leads to incorrect conclusions. It's precisely due to the importance of the stage of determining the significance of the functions of the carriers and the appropriate choice of methods for determining significance, consideration of the issue of determining the significance of functions and their carriers will be carried out through a theoretical review. First, the concept of the methodology of the determining significance. Secondly, domestic and foreign reference and regulatory documentation. Thirdly, a list of the most popular methods for cost engineers to determine the significance, superficial description of the algorithms for their application of methods and relevant business processes. Further consideration of methods for determining significance will be implemented in separate issues in the format of practical cases, practical cases with specific examples of the application of these methods in relation to eighth parts and assembly units for Block 2 or other intangible objects of analysis. We're talking about other blocks of training course Cost Engineering. The logic of classifying other stages of the value analysis as secondary or non-critical is as follows. The error in the analysis results directly depends on time and others. The resources spent on secondary stages, for example, if we have significant resources to generate detailed initial data, then the error in the analysis results, which is general, is logical, will be lower, etc. with respect to the remaining secondary stages, i.e. the more carefully the stage is completed, the lower the error in the final report, i.e. the complexity of these stages can be played in conditions of resource scarcity. Whereas the complexity of fruitfulness of critical stages is considered unacceptable. In this case, otherwise, the final report may have an absurd content, which in fact means that all the resources to perform the analysis were wasted. A more detailed comparison of the critical and secondary stage is presented on the slide. In particular, it's proposed to consider such comparison criteria as complexity of implementation, reduction of regulatory resource intensity when adjusting the project schedule, standardization of the task, requirements for the qualification of the performer or analyst, and interaction with related departments. In addition to the above slide comparative characteristics of critical and secondary stages of the value analysis, it should be noted that the most costly of the list of critical and secondary stages in terms of time and other resources are the stages shown on slide. Comparative characteristics of the stages of the value analysis, value design engineering by resource intensity. It should be taken into account that the possibility of deviation from the comparative characteristics given on the slide, comparative characteristics of the value analysis and value design engineering stages in terms of resource intensity due to the occurrence of additional costs and time, other resources associated with the design engineering, technological work, strength calculations, work on measuring analytics, etc. as part of an optional supplement of value analysis and value design engineering. The issues of accounting for the resource intensity of the stages of the value analysis will be discussed in more detail in the issue 15, implementation of the value analysis planning cost efficiency. The meaning of the types of classification of relative importance shown on the slide, I believe, is mostly clear to the audience. In terms of classification by objects of assignment and the need to separate the concepts of significance of functions and function carriers, reference should be made to the concept of engineering transition, which will be discussed in this issue below. In terms of classification on the basis of reduction or non-reduction to 1, as well as applicability to the function carrier of the functions, the meaning of creating this classification will be clear within the framework of considering the algorithm for introducing the values of the significance of functions into functional and combined models. Separate slides of this issue will be devoted to the consideration of this algorithm. Given that relative relevance is calculated on the basis of relative significance, classification can also be formed for this concept, but only in comparison with the concept of significance. It will have a simplified form, i.e., it's limited only to the division into the relative relevance of functions and the relative relevance of function carriers. The meaning of the introduction of the concept of relative relevance will also be revealed on the slides below as part of the consideration of the algorithm for introducing the values of the significance of functions into the functional and combined models. At first, listeners may have difficulty understanding the meaning of introducing the concept of relevance in addition to the concept of significance. If you explain on your fingers, then significance is a local characteristic, i.e., it shows how significant a function is as a part of a higher level function for the case of the value analysis, or as part of the function carrier for the case of value design engineering, depending on what type of analysis we perform. Relevance, in turn, is a cross-cutting characteristic that shows how relevant a function or function carrier is from the point of view of the highest level abstraction. For example, if the upper level abstraction is a bicycle and the lower one its many units, i.e., we are talking about the case of technical assignment, which was discussed in issue number 10 of the course, then each of the elements of the front wheel by calculating the relative importance indicator for them through a conditional relevance on the scale of the whole bike. The definition of significance and relevance from the point of view of practical implementation. In practical cases, from the applied rather than theoretical point of view, can be presented in form of a comparative table. From the table, we see that the determination of significance and relevance is performed in 2 stages. However, using different tools and for different assignments and objects, in particular for the stage of formation or tabular model, stage of formation of tabular structure and functional model, we are talking about the application of methods for determining significance, which will be shown in the table below, and assigning significance to individual functions in turn from the stage of filling out the form of a combined structure and functional model, it means the tabular model. The formulas for reducing the one and the distribution of significance according to their respective carriers are the tool. Consider the graphical flowchart significance relevance of models of an arbitrary object of analysis. We're talking about these two slides. Consider the graphical flowchart, which consists of three carriers of functions, i.e., in fact, it's an assembly unit that consists of three subcomponents. I.e., carriers can mean both assembly units, carrier 1, and carriers that are parts, carriers 2 and carrier 3. For which the corresponding designations SC and part are introduced. These designations are used in design engineer practice. In accordance with the definition of engineering transition introduced above, we are talking about visualizing a flowchart within the framework of value design engineering. Since at levels 1 to 3 function have already been replaced by physical carriers of function respectively. Its mistake is carrier 2, sure. On the slide you can see the line of engineering transition which delimits the upper part of flowchart on which the simplified structural model is displayed in, and the lower part of flowchart on which the functional model is displayed in a simplified form. Hence, the block flowchart significance relevance, it's not only a tool for visualizing the difference between the concept of significance and relevance, but also a tool for the visualizing the level of abstraction of considering structural model and functional model as well as their combined display, in particular in practice. This diagram will be used by us in the framework of practical cases where its suitability for analysis of assembly units with a small number of components and value design engineering process has been demonstrated. For carriers 2 and 3, which are details, fourth level containing functions, is not displayed on this slide because of the lack of space on the slide. Respectively, the engineering transition line for this media or for these carriers, for these two carriers, is also missing. Okay, let's consider the logic of filling the presented flowchart significance relevance in more detail in the table editor. Let's start with the second level where, as already indicated above, we have an assembly unit, carrier 1 and two parts, carrier 2 and carrier 3. To determine the significance of elements of the second level, significance assessment methods can be used that are suitable for analyzing the abstract structural from M2 to M11, see table of significance determination methods, or suitable for analysis or complete or close to complete structural model methods from 12 to 16, see table of significance determination model that will be described next on the next slides. Further, according to the relevance calculation formula presented above, the importance values for each of the function carriers are calculated. The next step is to calculate the significance values for functions, i.e., elements of second level. In this case, significance assessment techniques can also be used that are suitable for analyzing the abstract functional model from M2 to M11, or suitable for analysis or complete or close to complete functional models methods from 12 to 16. Then, using the relevance calculation formula presented above, the relevance values for each of the functions are calculated, As we can see, the process of filling in the numeric fields of the flowchart is significance relevance. It's kind of bidirectional, i.e. we first fill the upper part of the flowchart, then the lower one, and form a single model at the last stage. In order to verify the correctness of calculations, verification should be carried out periodically by comparing the total relevance of the function assigned to the carrier with the relevance value of the carrier determined by the formula. In addition, the data is a block diagram is significance relevance, must match the data from the combined model, which is used to build RQS and 6S diagrams. The methodology for determining significance is the theory of functional cost analysis. It's usually explained by the example of the hierarchy of functions of the upper and subsequent levels. A similar approach can be used in the formation of the technical requirements, but it's no longer applicable in the formation of technical assignment, since in technical assignment we must move from the hierarchy of functions, at least of the first approximation of the physical structure of the product, i.e., if, for example, the object of analysis is presented in the form of 10 basic consumer functions, then they should be replaced by 10 physical carriers or 10 function carriers. We will designate this replacement or conditional transition a function from function to function carrier. It's like the capital, then production, capital. Maybe it's not a very good parallel, but it's. I think it will be remembering better. Okay, the initial state, i.e. the state before the engineering transition of the flowchart we are considering, is presented on the slide. On this slide. The purpose of introducing the concept of engineering transition is to establish the boundary between the abstract description of the product in the form of a functional model which scientists and analysts usually deal with, to the physical description of the product in the first approximation, which can already be used by design engineers. In this context, the question arises: what is the difference between analytics or value analysis and design engineering or value design engineering? The simplest answer is as follows. In value analysis, we deal only with functions, and value design engineering with functions and function carriers. A more complicated answer is, in the value analysis, the primary structural model is formed on the basis of an existing product and its design documentation. Then a functional model is formed on the basis of structural model and design documentation, which is analyzed further. In the value design engineering, the primary one is a functional model, or, for example, its textual interpretation in the form of technical requirements or technical assignment, on the basis of which a draft of several structures in the form of design documentation is created, and accordingly several structural models variants corresponding to design documentation versions. In the literature on value analysis, such a difference is also described. However, it's described in most cases by divided into creative and corrective forms in value analysis. The disadvantage of such a formulation is its suitability for the academic environment and unsuitability for the practical environment due to the vagueness and ambiguity of the concepts of creativity and correction. The practical experience of the value analysis and the value design engineering shows that practitioners need a more understandable separation of the concepts of the value analysis and value design engineering corresponding to their field of activity, which was given by me above. The concept of engineering transition is a boundary concept, the introduction of which indicates the transition from the field of the value analysis to the field of value design engineering. Generally speaking, there is no algorithm for performing a direct engineering transition, i.e. replacing the top-level function with a function carrier. For example, we place the top-level functions to ensure the visual effects and ergonomics of the layout of the main bicycle components, which the carrier of the frame function, where the frame means a certain special structure made of metal or composite materials, and the replacement is carried out with the participation of design engineers who take into account technological strength and other parameters. There is no clear answer to the question why we replace the frame with the physical carriers and not with a system of electromagnetic fields, which theoretically can also perform the function of providing a visual effect and ergonomics and the layout of the main components of the bike. Indeed, in the case of electromagnetic fields, the visual effects bicycle units hanging in the air would be interesting. It's obvious that the concept of engineering transition is inextricably linked with the chosen degree of abstraction of consideration. For example, in the combined calculation model of a bicycle and front wheel, we see both the functions and the carrier of functions to which they belong. So, the engineering transition was made at the level of degree of abstraction corresponding to the level of front wheel. Therefore, if the engineering transition occurs at the level of detail, i.e. a physically indivisible object of analysis, then we are dealing with a combined low-level model. Therefore, if the engineering transition occurs at the level of detail, i.e. a physically indivisible object of analysis, then we are dealing with a combined lower-level model. Let's describe an approximate algorithm for choosing the level of abstraction of consideration, choosing methods for determining significance, and adding them to the functional model. The first, the degree of abstraction of the consideration is selected based on the availability of initial data and the formulation of the case of the customer for the analysis. A decision is made whether complete of abstract structural and functional model will be formed. Second, columns are function number, type of function, function description, and function carriers of a functional model being filled in. Third, the compatibility group of the significance determination methods is determined. See slide compatibility groups of methods for determining significance. The list of methods used for the determining significance is determined. The designations of the methods used are entered on column headers from M2 to M18 of functional model. Fourth, to the formed list of functions or functional metrics, the methods of determining significance are applied alternately, and the cells corresponding to the functions of the columns from M2 to M18 of the functional model are filled in. In the column M average or average relative significance of functions, the average relative significance of functions for values from the columns M2 till M18 is automatically calculated. Let's describe an approximate algorithm for adding values of relative importance to the combined model and calculations based on them. The first, based on data from column M average, we filled column unreduced relative significance of function. This marked like this. Function carrier or function. For a list of function carriers in the column function carrier and their corresponding functions by entering values marked unreduced relative significance function. The second, in column for unreduced automatically unreduced relative significance of function carrier automatically detected for function carriers as the sum of the relative importance values of function assigned to an individual carrier. Third, next, the conversion to a unit of significance for the function carrier is performed by filling the column relative significance of function carrier reduced to the one local the need to reduce to the one cause the fact that the significance of the functions of the columns from M2 to M18 of the functional model is determined by various methods. If the significance of the functions is determined using the one technique, not a group within the compatibility group, then reduction to 1 is not required. However, the probability of incorrect determination of significance increases due to that. Then it's recommended to use at least 3 techniques within the compatibility group. Next. Further, based on the given values of the significance of function carrier or parameter marked relative significance of function carrier, reduced to 1 local, determined relative significance of function local and its integer to the corresponding column. Then, according to the formula for calculating relative importance, see the slide relative relevance, the column is filled in relative relevance of function carrier function end-to-end. Moreover, for function carrier to end-to-end relative importance, end-to-end relative relevance, it's not calculated using a formula, but it's assumed to be equal to the given relative relevance of function carrier. Further, based on the result of the application of methods for determining relative relevance with the carrier of function, column is filled by relative relevance with the function carrier of function. After that, the columns is filled in end-to-end performance quality of the function carrier, degree of relevance at fulfillment quality will be devoted to the issue of applying methods for determining relative relevance with a function carrier or function. Then calculated maximum spans for function carrier in accordance with the business plan by multiplying the values from the column relative relevance of function carrier or function end-to-end with the values of the actual cost of suppliers technical commercial proposal for the function carriers, which are shown on the initial data tab of the calculation file. And the corresponding column is filled significance maximum of function carrier and significance maximum for function. Based on the results of all this calculation, the RQS diagram is constructed, which the practical meaning of specifying the parameters of significance and relevance in the standard analytical report, RQS report, or the report's relevance quality of implementation of the function carrier and costs has already been considered by us in issue number 10, Analogy of the Value Analysis Methodology and Technical Specification Information Approaches. The practical meaning of specifying parameters of local significance in analytical reporting doesn't make sense, since local significance is an intermediate stage in the process of calculating relevance. In other words, the end user of analytical reporting isn't interested in this parameter in 99% of cases. Let's perform a brief overview of the contents of the table of methods for determining significance. First, let's look at general structure of the table. The upper left part, we see the names of columns, its particular the block name or the methodology for determining significance, in accordance with the concept of the domestic school of the value analysis, and the concept set out on the standard VDI 2808 part 1. Then in the central upper part of the table we see the name of the block of columns, applicability of the context of possible areas of activity, which includes the block's name of possible areas of activity and application features. In the evaluation criteria column for each methodology, a division is made into basic initial data and tools and resources. The sub-blocks on the name of possible areas of activity block fully correspond in name to the conceptual blocks of the cost engineering channel. what makes it possible to limit the applicability of techniques in various fields, namely in design management, accounting, industrial design, marketing, project management, HR, commercial negotiations, and modern virtual reality objects. The final group of blocks in the upper right part contains columns related to applicability, conditional accuracy of significance, assessment methods, and compatibility constraints, as well as resource intensity. Let's briefly consider each of the methods given in the block name of the methodology for determining significance and the column domestic school of value analysis and value design engineering. The names of similar methods in the column VDI 2808 Part 1 are given for reference. In my opinion, a more detailed description of the mechanism of application of the methods given in the table should be considered most effectively within the framework of practical cases. So, M1. Methodology of equivalence. Within the framework of the approach used in this methodology, all carriers of abstract structural model functions are assigned the same equal importance. The use of this technique in practice isn't recommended even within the framework of analytical reports of the first approximation. Therefore, the corresponding cells for this technique are not filled in. The only purpose of adding this technique to the table is to mention it in the context of incorrect use in practice. And 2. ABC analysis method of the traffic light model according to a group of evaluation criteria. They are combined in one line since they are conditionally identical in the context of their application and functional cost analysis. The explanation in parentheses expert and neural network means that both traditional expert assessment tools and specially trained neural networks can be used when performing the analysis. However, information obtained from neural networks must be verified by an expert before it can be taken into account in determining significance. Thus, the function of the neural network in this case isn't completely replace the expert, but to increase the complexity of his expert assessment. For the other methods listed on the table, the meaning on this explanation is similar. The absence of such an explanation means only traditional methods of expert assessment are used in the application of the methodology for determining significance. The use of the methodology implies the analysis of the design documentation of the function carriers, including a 3D model specification, drawings, and technical specification, without evaluating the economic information about the costs of their production. The significance is assigned to the carrier's function based on the expert assessment of the design engineer by comparing the level of complexity of the design, the volume of installed equipment without using actual technical and economic information on research and development costs, production costs, purchase prices of purchased products for carriers of functions. M3. Method of working group expert evaluation through open-closed voting. The application of this technique implies to use the members of working group of design engineering documentation available at a given time for 3D models, specification drawings, and technical specification, and other documentation describing for the function carriers without additional requests for actual economic and other information. The significance is assigned to the carriers of function based on the expert assessment of the design engineer by comparing the level of complexity of the design, the volume of installed equipment, etc., without using actual technical and economic information on R&D costs, production costs, purchase prices, or purchased products for carrier of functions. M4. Method for estimating the average market price of finished products. Functions or options of function carrier. The methodology includes an analysis of the average price of function carriers, components of the object of analysis, by analyzing available information sources. We are mainly talking about the price lists of online stores and etc. The limitations of the methodology for estimating the average market price of the finished products include the fact that the methodology can be applied to a limited range of products, in particular for consumer goods, information on the market price of which is publicly available. M5. Method of mentioning products function options within the framework of unofficial promotional tools, bloggers, analysts, invite experts, and etc. The methodology includes of analysis of frequency of mentions of consumer functions by conditional independent bloggers in the framework of reviews, unpacking, comparative tests, and etc. An analysis of the mentioned characteristics, the quality of implementation of consumer functions, and etc. M6. Method of mentioning products, functions, options within the framework on official promotional tools, presentation, exhibitions, advertising, etc. The methodology consuming functions of the official promotional tools of the product manufacturer, advertising, promotion, PR, promotional, public relations, exhibitions, publications, direct mail advertising, and personal contacts, personal sales, personal promotion, consultations, training, etc. M7. Method of comparing combined technical and economic parameters, unit cost per unit, unit of mass, and etc. And M8. Method of comparing geometric parameters, comparing geometrically similar objects. The M7 and M8 techniques can be applied to the structurally and technologically comparable carriers of functions. For example, components of the fuselage or wing panels of an aircraft, components of the hull of a vessel, components of the car body, components of a bicycle, for example, it's our old friend front and rear wheel, and etc. In the case of placement of equipment, of systems, and the components of the product, these parameters also should be taken into account when assessing the significance. In the case of the M8 technique, the significance is assessed by direct comparison of the geometric parameters of the function carriers and the composition of the object of analysis. M9. Method of forming a proportion based on the amount of R&D costs, and M10. Method of forming a proportion based on the labor intensity of production. At the part of the application of the M9 and M10 techniques, as their name implies, the importance of function carriers is assessed either in accordance with R&D costs for each carrier or in accordance with the actual expert costs of their production. Accordingly, the obvious limitation is the inability to assess the significance of functions, i.e., this technique is suitable only for assessing the significance of function carrier, the driver of R&D or production costs. M11. Method of forming a proportion based on the supplier technical and commercial offer. The methodology implies assigning importance to function and their function carrier in proportion to the purchase price of purchased products specified in the technical commercial proposal or information from unofficial in a tabular format, and etc. Commercial calculation of varying degrees of detail, for example, tabular cost breakdown, and similar sources of information. M12. Method of exclusion. The exclusion technique consists in describing a set of possible local and complex effects that arise in the case of exclusion of individual functions from the functional model of the object of analysis. In fact, a search is performed for possible combination of all functions and the description of the number of effects from their exclusion of this combination. If the exclusion effects coincide with the failures described in the FMEA analysis, if there is an FMEA analysis in a report, the effects can be assigned the appropriate significance values from the FMEA report. In the absence of the FMEA analysis report, as a first approximation, the significance of the effects can be classified as follows. the effect is assigned of a value of 1 for its exclusion leads to a risk of non-compliance with the technical assignment or impossibility of operation, and value of 0.5 if it's possible to continue operation, i.e. with an acceptable of accordance with the technical assignment reduction to the function of the object of analysis. If resources are available to conduct a more detailed analysis, the number of expert coefficients can be increased to improve the accuracy of the assessment. The disadvantages of the exclusion technique include significant compilation of the task of evaluating possible effects, for example, for complex functional model, i.e. for the objects of analysis, having a complex structure since the number of combination or excluded functions and evaluation of possible effects increases significantly. And the second, the need to attract highly qualified specialists in the field of operation and design engineering who will be able to describe the effects that arise in case of exclusion of individual function carriers from the product design. The next, M13, FMEA data usage methodology. The methods of using FMEA analysis data is generally similar to the exclusion methods, except that's not in case of excluding individual components from the product design that is analyzed, but it's possibility of their failure. The difference between these two similar at first glance methods is that the method of using FMEA analysis data implies the presence of FMEA analysis report, which in most cases is provided by the developer together with a set of design engineering documentation, i.e. the number of cases which possible failures is limited by the FMEA report. In the case of the exclusion methods, the number of cases with the consequences of exclusion is limited by the mathematical number combination of options for excluding function carriers from the design. As part of the application of the methodology for using FMEA analysis data, the priority is considered to be use of significance indicated in the FMEA analysis report. In terms of limitation of FMEA analysis use methodology, the methods analysis data is more versatile and less time-consuming than the exclusion method, since the complexity of applying the methods for using FMEA analysis data is limited by the number of failures mentioned in the FMEA analysis report. The disadvantage of this technique is comparison to the exclusion technique is lower accuracy associated with limiting the number of considered cases of failures. M14. Method of forming the proportion based on the actual share of the analyzed object in the structure of direct costs, according to the actual calculation. The use of the methodology implies assigning the importance to the carriers of functions in accordance with their share in the structure of direct costs of an analog of the previous generation for this price structure of the direct cost structure of an analog for competing companies. The disadvantage of the technique is the need for reliable calculation for incoming components, including purchased products. Thus, the limitation of this technique that is used only for internal production, since the probability of obtaining reliable calculations from an external supplier is extremely low. M15. Method of random multiple formulation of functions. The technique implies the arbitrary formulation of the maximum possible number of functions for each carrier from the structural model composition by brainstorming. Next, the unification for the options for the formulation of functions is performed combining similar formulations into one and adding them to the summary table of the number of functions assigned each carrier is in unlimited. Further, in the summary table of media and their functions, the proportion is complied, reduced to 1, and the significance is determined in proportion to the number of functions assigned to each media, or to each carrier. The formulation is carried out by a group of experts or specialists or the working group with a time lag within the framework at least to 30 minutes meetings. The lag between meetings is from 3 till 5 days. The application of neural network formulation is implemented by formulating functions through the next interface of a specially trained neural network. In this case, training means uploading data on the marketing analysis, design engineering, etc. to a neural network. Thus, training neural networks and the associated additional costs become another limiting factor. The use of publicly available neural networks in turn reduces the accuracy of the analysis results due to the universality of the databases used in them. Within the framework of meetings, using brainstorming as well as analysis is working order between meetings, all participants are recommended to have auxiliary information in front of their eyes. For example, photographs of the object of analysis or its analysis presentations, 3D models, drawings, and technical assignments. Meetings are recommended to be held in the morning so that all participants in the state conducive to creative thinking. The use of methods of arbitrary expert formulation of functions is possible both in face-to-face group execution and in accordance with the principles of Delphi method, correspondence, anonymity, structuring the information flow by the moderator of the study. The creation of techniques based on the use of a text interface of neural network has a limitation associated with the inability to take into account additional contexts which cannot be formulated in the form of a text query, the design of the object of analysis, operating condition, life cycle parameters, and etc. Simply put, if there is only a text interface, queries are too abstract, even for the case of the formation of an upper-level abstract functional model. In the case of widespread use of neural network interfaces that allow processing input data in the form of drawings, 3D models, tables, and etc. In addition to the text input data, formal models can solve this problem. M16. Method of pairwise comparison of functions. The methodology implies a pairwise comparison of functions by a group of experts, members of working group, on a third-party specialist, using a standard form of a pairwise comparison matrix. The technique will be demonstrated in more detail using a practical example, which will be discussed below this video. The features of the pairwise comparison method, which is usually not mentioned in the publication describing its manuals, etc., is its conditional two-level in particular. If we take the formation of the classical 10 by 10 matrix at the first 10 on 10 matrix at the first level of the placement of the comparison results into it, then the second is precisely a pairwise comparison, i.e. a comparison of two functions, which can be performed both on the basis of conditional expert assessment, i.e. actually taken from the salient, relying on the expert's experience, so on the basis of all-in-depth review for each considered pair, for example, by forming a list of evaluation criteria from two columns, the heading of which will be this pair, or using other well-known comparison methods. Two different options, in my opinion. The approach using unreasonable expert assessment being less time-consuming and significantly inferior in accuracy to the final values of significance of functions or their carriers based on the results of using pairwise comparison technique. The method of pairwise comparison using a neural network is completely similar to the method of expert pairwise comparison of functions. However, instead of experts and members of the working group, the pairwise comparison is performed using the next interface by the neural network, a specially trained neural network. By training, in this case, as in the case of neural network formulation methodology, it means uploading data on marketing analysis, for example, design engineering, etc., to the neural network. Thus, training neural networks and the associated additional costs become another limiting factor. The use of publicly available neural networks in the case of using the pairwise comparison technique is also possible, taking into account the disadvantages of such neural networks mentioned above. The application of the pairwise comparison technique, as well as the application of method of arbitrarily multiple formulation of functions, is possible both full-time group execution and in accordance with the principles of the Delphi method. The basic limitation is the need of the automate tabular models of pairwise comparison if they are large, for example, more than 10 rows or 10 on 10 metrics. Thus, in the case of large models, the use of artificial intelligence is preferable. In particular, the neural network pairwise comparison technique that will be seen above. The neural network pairwise comparison technique has no restrictions related to the volume of the model for pairwise comparison. A person can effortlessly make a pairwise comparison for a model with a conditional volume of no more than 10 rows. M17. Other methods of determining significance. Other methods of determining significance in this case include scientific methods for solving multi-criteria tasks that require significant costs for R&D and the involvement of highly qualified specialists. Highly qualified specialists means specialists who are more related to theoretical research than to solving applied problems of functional cost analysis, value analysis, and design engineering within the framework of joint work with specialists of the project working group. The methods presented in the table can be divided into conditional compatibility groups according to their degree of accuracy. Simply put, when analyzing a component, it's necessary to take into account the accuracy indicated in the table of methods for determining significance and select methods with the same degree of accuracy, using thus forming a conditional compatibility group according to the chosen degree of abstraction. For example, full structural and functional model, the groups high and medium correspond to a greater extent, etc. In the table of methods for determining significance presented to the audience, conditional compatibility groups are indicated in different colors. The column which lists the methods mentioned and the value in the standard VDI 2808 part 1 for comparison with the methods of determining significance used in the domestic value analysis school doesn't include all methods recommended by the above-mentioned standard. The reasons of this in this case is that we VDI 2808 part 1 standard provides a universal of a mixed list of tools that can be used at all three levels of cost engineering in accordance with the classification proposed in our training course, talking about cost engineers of first, second, and third levels, as well as at high levels of management or levels that are not directly related to cost engineering, for example, in the departments that form the business plan of the project. Such not included in the table tools include DFMA, Design for Manufacturing and Assembly, which in turn is also a set of techniques used in the development process, allowing in particular to reduce the number of parts of assembly units and increase integrated manufacturability or manufacturability of parts, as well as the intermediate and final assembly. The non-inclusion of this tool is due to the fact that, for example, it's not entirely clear to me how it can be used to determine the relative significance of functions or function carriers, since if it's, for example, the number of cost drivers defined within the framework of DFMA is selected as a comparison criteria allowing to reduce the number of parts or increase their manufacturability, then the advantage is in number of cost drivers for some parts is no way characterize their importance or their relevance relative to other parts for which cost drivers are missing. Simply put, the presence of this tool is the list of tools for determining methods for assessing significance in the VDI 2808 Part 1 standard isn't entirely clear to me personally. In relation, for example, to the FMEA tool, the logic, in my opinion, is more obvious, namely, we can cite those details with which a greater number of possible filers are associated to be more significant. Therefore, this tool is present both of the column Domestic School of Value Analysis and Value Design Engineering and the column of VDI 2808 Part 1. The table also doesn't include tools such as functional analysis or you can see this formulation in standard VDI 2803 Part 1. In this case, I would not like to delve into the existence of contradictions related to translation. For example, that we consider functional and functional cost analysis. We're talking about the VDI 2803 Part 1 standard and methods for determining significance in another standard VDI 2808 Part 1. Placing in the VDI 2808 standard as a tool for determining the significance of such a position as price analysis and mentioning in the description of various accounting systems, absorption cost and variable cost, and also raises questions related to the discrepancy between the level of abstraction of consideration and the complexity of approaches to analysis. The proposed list of methods correspond to more general design analysis as opposed to a narrower value analysis and value design engineering. The formulation of these questions alone can't take quite a long amount of time and, in my opinion, doesn't relate directly to the object of consideration of this issue, namely the methods of use themselves. Thus, with a significant discrepancy in the concept of presentation and applicability of the methods for determining significance set out in the VDI 2808 Part 1 standard with the concept of the cost engineering course, I referred the methods to not included in the summary table. The summary comparative table methods for determining the relative importance of functions doesn't include a feasibility study tool due to the fact that, firstly, in most cases it has industry-specific features, and secondly, it's excessively time-consuming to use as a tool for determining significance within the framework of the value analysis and value design engineering. In other words, the complexity of forming a full-fledged feasibility study for a product exceeds the complexity of conducting the value analysis. Therefore, the feasibility study cannot be an intermediate stage tool with the framework of the value analysis or value design engineering. Also, the table doesn't include a technique under the designation point system, mainly due to the fact that it's not entirely clear what kind of methodology we're talking about here. I would venture to assume that we're talking about the functional point analysis technique used in software development. The table doesn't include a tool such as stakeholder analysis. Since the opinion of interested parties within the framework of the VDI concept proposed to the not VDI, value design engineering. Sounds similar, like a VDI standard. Concept proposed in our training course is taken into account firstly as a stage of the forming functional requirements, technical requirements, and technical assignment. And secondly, as a stage of assessing the degree of customer significance, for degree of customer satisfaction, which will be discussed in more detail in issue of number 12, degree of satisfaction and fulfillment quality of functions and their carriers, regarding to the QFD with quality functional deployment with house of quality. Methodology. I will not give detailed comments related to the fact that quality issues, to the extent that they should be taken into account in the value analysis and value design engineering, can also be reflected in issue number 11. Regarding SWOT analysis, suppose comments are not required since the type of analysis generally used in strategic planning, and its degree of abstraction, if we use the terminology of cost engineering, it's highest possible. The strength and weakness of SWOT analysis have been analyzed in sufficient detail in many articles. So I suggest limiting ourselves the general conclusion that using SWOT analysis to determine significance in the value analysis and value design engineering is difficult to implement. Personally, I haven't seen any practical examples of such use of this tool. With regard to profitability analysis of cost-benefit analysis, we will follow the same logic as with regard to SWOT analysis. In the context of consideration of the table of methods for determining significance, the following statement can be made. The skill of a cost engineer is determine the significance of functions and their carriers with the least expenditure of resources, i.e. by applying a few methods as possible they are most appropriate to the chosen level of abstraction. In this case, resources mean not only time-consuming but also material resources, since most of the methods require the involvement of either experts from the working group or third-party independent experts. An indirect indicator of the skill of cost engineer is the balance of the RQS diagram as well as the absence of significant discrepancies in the 6S diagram. The presence of significant discrepancies in the two indicated diagrams may indicate either significant errors in determining significance or significant distortions in the structure of actual costs according to technical commercial proposal for components associated, for example, with ultra-high margins. The reason for the ultra-high marginality in turn may be a small, serious, and exceptional market situation, like a monopoly, a deficit situation, and etc. In the light of the above-mentioned positive aspects of the value analysis and value design engineering methods, as well as a table of significance methods considered by us, which in particular mentions the concept of market price, it should be noted that there is such a limitation of the applicability of these methods and situation of lack of information about fair or market prices. This limitation of the applicability of the value analysis and value design engineering can be formulated as follows. The most accurate results of analysis and design engineering using in value analysis and value design engineering methods can be achieved in a normal market situation, i.e. in a situation where analyzed direct product costs consist of fair or market prices for purchased components, raw materials, and etc., if we use international accounting terminology. In our course, we mainly use the classic type of visualization in the form of columnar sequential histograms. In addition to consecutive columnar histograms, mirror bar charts are often used in domestic school, diagrams in which two or one or two relative or absolute parameters for one function or function carrier are reflected mirrored relative to the axis. In particular, relevance costs diagrams, the obvious disadvantage of mirrored bar charts is that they display only two evaluation parameters, whereas the sequential charts that we built in our example, 3 and 6 compared parameters are displayed. In practice, depending on management requests, any suitable forms of visualization can be used, in particular those proposed in the VDI 2808 Part 1 standard. And the last, the automation tools discussed on this slide are mentioned in the table of methods for determining significance in the section Tools and Resources of our table. It was discussed above. However, we would like to highlight the importance of the issue separately, in particular due to the fact that the process of planning the complexity of the work of the working group, which will be in more detail reviewed in the issue number 15, implementation of the value analysis planning costs and efficiency, often doesn't take into account the importance of automating the process of determining the significance of functions and their carriers. In conclusion, I would like to add the main criteria for choosing the correct methodology for determining significance, as well as in the case of selecting the most appropriate classification of functions. For example, the basic classification, which we discussed in issue number 7, is the convergence of the results expressed in the balance of the design engineering according to the RQS criterion. In other words, the correspondence of the significance of functions and their carriers to the actual cost for these functions and carriers, subject to confirmed reliability of the analyzed cost values, which, as already mentioned above, it can be implemented either in case of independent production, an option with analysis of direct cost for functions and carriers, or in the case of an analysis of market or fair price, an option with a technical benchmarking or reverse engineering. That's all for today. All bye.